Okay, we're recording.
All right. All right. Well, welcome everybody to the evidence-based triathlon or triathlete podcast. We're having some technical issues tonight, and so I'll be hosting. John Mercer is here, and I'm Ted Gerard, and we are live with Jon Thornham from Flo Wheels, the makers of some of the fastest wheels on the planet. And tonight we are really excited because we're going to talk about wheel selection, in particular wheel selection for triathletes and what we should be looking for when we buy wheels, some of the limitations with wheels, and just basically ways to potentially make us faster on the bike. So welcome John and John.
Hey, thanks for having me. Happy to be
No
here.
problem. No problem. So, John, we've obviously talked before, and John. For those of you that don't know, John is Las Vegas based, like we are, and we've done quite a bit of research with John, and we've looked at rolling resistance, we've looked at vibration, we've looked at different tire combinations and different pressures. So we've done a lot of work with John, and so it's been a great relationship so far. And we're going to be doing some more work with him coming off in the near future. But what I really wanted to start off talking to you about today was kind of the factors that go into a wheel. So like aerodynamics, rolling resistance, vibration, and what really we should be looking for. So in a nutshell, do you want to kind of give us an overview of some of those factors that we could be, that a triathlete could be looking for when they're looking to purchase a wheel or to choose a wheel to race or ride on?
Yeah, I mean, there's really a few components that you really want to look at. Number one, and the first thing you want to always think of is you want a wheel that's made by a reputable manufacturer. Especially if you're looking at something carbon fiber based, you can still get really cheap carbon stuff, and it's not safe to ride. So we always recommend going with somebody that's reputable. You're going to want a wheel that's built really well, and when I say built really well, I mean you're going to have the good quality components that comprise a wheel. So you're going to look at good hubs, good bearings. You want great spokes, something like a Sapum CX Ray spoke or something similar like that. And you want a rim that's made really, really well. If you have all of those components, what you start to look at is how is the wheel designed and what is its intended use. So if you're looking at somebody that's recreational based, you're still going to want a wheel that's going to be built really well. It's going to give you a lot of longevity. You're not going to be in the shop getting it through. You're not going to break spokes on a regular basis. You're probably going to want something that's at least somewhat aerodynamic, and you're going to want something that accepts some of the newest tires out there. You want something that's tubeless compatible, and you also want to consider rolling resistance. If you're moving more to a race perspective, well, then things like aerodynamics and rolling resistance become more important because those are the things that are actually saving you time when you're racing. Aerodynamics is very, very important when you look at it from a time savings perspective. It's the largest component of a wheel that will reduce the amount of time required for you to complete the same distance. Rolling resistance would be the second. And then after that, weight is a very, very, very distant third. It's pretty insignificant. When compared to aerodynamics, I mean, you're really looking at a factor of like 60 to 1. We've done a lot of studies with the on weight versus aerodynamics. We've got some really cool blog articles on that as well. But your main focus is, and I'm sure we'll talk more about them, are aerodynamics and rolling resistance that you want to look at when selecting a really good wheel for racing.
Let's start out with weight, since that's is always people think about weight, right? But
Yeah.
I, as a triathlete, very rarely do I have big climbs in a triathlon, right? And that's the only, correct me if I'm wrong, that's the only time when weight really would play a role. If I've got, let's say a triathlon with 5,000, 6,000 feet of climbing, which is very, very rare. Is that correct?
Yeah. So, and here's the thing. We did this study with a guy named Ryan Cooper. And if you don't know who Ryan Cooper is a brilliant mathematician. He's been in the cycling space, works with most of the Pro Tour teams, or has at some point. His kind of claim to fame, or how he got started, was he was studying or trying to complete his PhD in mathematics, and was a cyclist. And he was watching the Tour years and years ago and saw that the Trek team was using some sort of computational model to analyze and predict riders' times and specific wattages. And the math model that they were using was taking about 7.5 to 8 hours per rider per day. So, I mean, it was giant. So he kind of put himself to work He did the same thing that these guys did. It produced a better result, and he was getting the answers in about 3 seconds.
Right.
So Ryan Cooper's just, I mean, he's just a brilliant guy. So we wanted to study um, what happens to a rider's speed when you take a aero wheel set and you take a that's heavy. So we used like I think it was 2,200 grams, almost like
Ooh,
theoretically heavy. I mean, it's a lot. It's
that's a heavy wheel
a
set.
heavy wheel set, right? And then we compared it to like a theoretical set of 1,100 grams, just kind of like a out of the box,
Yep.
standard wheel. And there's not a single. There's I think there's Savage Man, which is the most elevated Ironman course in existence. The arrow wheels like dwarf it. I mean, it's not even close. The only climb that we could find that's like in a sanctioned race was the Alpe d'Huez,
Yep.
and the theoretical. I mean, when I say theoretical, like it would be really difficult to make a set of wheels that weighed 1,100 grams. It's not really. I mean, it would be tough to do. So that set of wheels in that race and that climb, which the Alpe d'Huez is just insane, it only beat the arrow wheel set at 2,200 grams by 3 seconds.
Yep.
And, what we have today from a product when we first did that was back when we only had aluminum based rims. We now have wheels that are a lot more aerodynamic. They have lowered rolling resistance and they're also a lot lighter than 2,200 grams.
Right.
So there's really not a situation now where weight is more important than aerodynamics. You got to think too, a lot of people see weight is really, really easy to measure, right? So if you
Right.
think about going and you're trying to figure out what components you want, the way I always describe it is everyone can get a kitchen scale or a bathroom scale and they can weigh like to the gram. So it's really easy to become obsessed with like, oh, I want to lower the weight because that's so important. If somebody's going to get a new component and they want to say, well, how much does this lower my overall drag value? Well, that's really difficult to do. I mean, you got to spend hundreds of thousands of dollars to get to a wind tunnel to test it. So it's kind of like the easy thing to see when you look at it from a weight perspective, but it really has very little importance when it comes to things. If you look at it from a sprint perspective, there's a really good another guy in the space named Tom Anholt who's done a lot of work. He's looked at it from an acceleration perspective, and even in sprints, in like crit racing, it's a factor of 60 to 1 where aerodynamics is still more important than weight. So it's a very common myth. People think that aerodynamics is on par or not as important than weight, but it's just the opposite. I mean, you gotta think an empty water bottle too weighs like 80 grams, right? So even 100 grams of difference uh, is really pretty insignificant.
Yep. Yeah. And I think especially in triathlon, because, you know, our our triathlon bikes are being weighed down by a bunch of stuff anyways, right?
Right.
Like the average triathlete, let's say a half Ironman is going to be carrying 2 or 3 water bottles, a bunch of nutrition.
Yeah.
They're going to be wet when they get out of the
Yeah.
water, right? They're, the weight really doesn't seem to factor in nearly as much for me. And as a triathlete, my number one thing is always aerodynamics. Like
Yep.
I'll put more stuff on my bike that to be more aerodynamic than try and take weight away.
Yeah, definitely a good choice. And there,
Yep. Yep.
you got to think too. The other thing from a triathlete perspective is you get up to speed
And you stay
and
there.
you stay there, right? There's not a lot of acceleration, there's not a lot of deceleration. So from a weight perspective, we're kind of able to take a lot of that acceleration piece out of it. And the other thing, especially for a triathlete, is that you are on your own, right?
Yep.
Yes, we can argue that even at the 10 meters that there's still some draft benefit. Yes, of course. But you are basically cutting the wind on your own. So that aerodynamic portion and component is just even that more important and that much more
Yep.
important because you do have to make sure that you are being as aerodynamic as possible.
Yep. Agreed.
Mm.
Okay. So we've kind of put the weight weenies to bed. So
Yes.
let's talk about aerodynamics.
Yeah.
So let's say we have a wheel with good hub, good spokes, good
Hmm.
components. What makes a wheel aero versus a carbon wheel? Let's talk about carbon wheels.
Yeah.
Okay. Uh, a good aerodynamic wheel versus one that's not so good. And is there really that much difference between wheel manufacturers?
Yes, there is. So, but I'll say that with sort of a caveat.
Okay.
It's really easy to go and say, I'm going to make a wheel 60 millimeters deep, right? The the people that make wheels that are designed to be really fast think about it as a whole picture. So that means that, like when we design a wheel, the way that we do it is we've collected hundreds of thousands of measurements on road to understand what yaw angles you see. So what angle the wind hits you when you're riding. And so based on that information, we then will use computers and we use an optimization algorithm. And we also will go out and we will find a very specific tire that we want to use. We'll kind of model that around a tire or tire size. What we then do with all of that information is we put it in the algorithm, and the algorithm will iterate over hundreds of rim shapes to sort of solve for a complete system. Now, in that algorithm, it's weighted, but we have a weighting component that's focusing on reducing your drag, but we're also focusing on making sure that the wheel stays stable if you get hit with crosswinds.
Right.
The original wheels that came out that were deeper section, it was basically just like a V shape if you were to cut it and section it. And I mean, there's an old Blackwell wheel. I think it was designed by John Cobb years ago. I think it was like 200 millimeters deep. It was crazy. It's a funny looking wheel to see. It's got like these spokes that are these like they're 4 inches long. It's kind of a funny wheel. But what happens when you get a wheel like that is it's just so difficult. And because of that profile, it's very, very difficult to handle in the wind. So it may be fast, which and they're actually not as fast as the shapes that we make today, but you got some speed performance, but it was like riding a bucking bronco. I mean, it was just as a triathlete, and you're trying to stay down on the bars, you as your body is the largest drag component that you can produce. So if you're staying in that aero position, that's great. But when you put these old wheels on, you were so uncomfortable handling that you were coming up out of the bars on a regular basis. So you're actually the wheels kind of making you lose time because you have to be out of the aero position so long to handle it. So when we're looking at designing a good wheel, we take all of those things into consideration. So we're really driving down that the amount of drag that you're going to see. We're really increasing the stability that you're going to see at that depth, and we're making sure that we're integrating that with a tire so that the whole system works really well as a package. There are other companies out there that make really, really good wheels, right? And I'm not saying that they don't. If you're going to compare the companies that are actually doing some R&D and putting some research into it, the differences between the top level is there's differences, but it's kind of like which one's better. I'm not sure. It really it depends on your bike fit, your own fit. There's a number of different things, but the value you're going to get from those is all very, very similar. There are other brands too that just kind of go out and they just say, hey, we're going to make a 60 millimeter wheel. I go over to Asia, I pick up an open mold, which means anybody can use it. There's not really a lot of R&D in those. They're typically not as aero. They're not really designed around a system. They're not as stable, and you kind of run into some of those. And a lot of times they're made with cheaper components as well, and so you just run into problems. So aerodynamics optimized, it makes a huge difference. We were able to, when we first used our optimization algorithm, we already had fast wheels, but we were able to improve the aerodynamics alone by a factor of like 23 to 25%. So from a company that was already making something fast, we were able to gain that much benefit, which is pretty significant.
Okay. So you said that you chose a particular tire to mate with your wheel. And now we're
Yes.
seeing some companies that are actually producing their own tire to mate with their specific wheel,
Yeah.
right? So which wheel slash, or so which tire did you guys choose to optimize Flow wheels to, and why?
So here's tires are a very, very interesting animal. I've got a really good friend over at Kenda Tire he's a pneumatic tire engineer. I've talked with other guys that have made tires or tried to make tires, and they're an incredibly difficult thing to manufacture, especially when you're trying to make them aerodynamic.
Yeah.
It's a very difficult process. But a tire as a whole, to me, has always been a three-legged stool, and I think of it that way. So there's three components to a tire in order for me to sort of say this is the best tire for kind of everyday use or racing or whatever it is, I look at the aerodynamic um, makeup of the tire. So how well does it perform aerodynamically? What is its rolling resistance number? And how durable of a tire is it? And if you look at some tires that are really, really low in rolling resistance, there's a Vittoria tire. It's like the Corsa. I always forget the name of it, but it's
Forces speed.
there we go. Thank you. Corsa Speed. I knew it was Corsa something.
Graphene
G
2.0.
plus 2.0. Yeah, that's it. That tire, from a rolling resistance perspective, is just an animal. I mean, it's beautiful to look at.
Yep.
You take that thing to the wind tunnel, it looks kind of like a pig in a wind tunnel. It's not so great. And that's nothing against Vittoria. I think they're making, I think what they're doing with that tire is remarkable. It's a great work. But if you look at its durability, they're known to puncture really quickly. They wear really quickly. Those are the things that we've noticed with those tires. And so I've kind of reduced down to one leg. If I look specifically at the tire that we really like, which is a Continental GP, it used to be a 4000 S2, and they've now discontinued that. They've gone to the 5000. It's got really, really good rolling resistance for what it is. It's got great durability in our perspective, and it's got really good aerodynamics. So from all of those factors combined, I think about me in a race situation. I want a tire that's durable, that I'm not going to really worry about getting flats or puncturing. They make a tubeless and a tube version, which are equally just as good. The rolling resistance is low, so I'm not really thinking about that. And from an aerodynamic perspective, it just gives me all the benefits. So we go and we designed all of our latest road wheels on those tires.
Okay. So you're designing off of the GP 5000 is what you're saying.
We did, and we specifically started our optimization algorithm with a 28 in mind,
That was
which
my
is
next
funny.
question.
Yeah, no, it's funny that I remember when we first started back in 2011 and started modeling wheels and running them through CFD. We picked a 23 millimeter tire, and at the time, that was like we
That was
were
wide.
we were like pioneers and like saying, "Hey, we're going with 23s." This was a big deal. It was huge. But this time around, when we went to the wind tunnel, we didn't even take 23s. The smallest tire we tested was a 25 millimeter tire. And it's just the benefits that we've learned. And we first really picked this up back in 2016 after we had produced our um, second generation of wheels. Tom Manholt, same guy I was talking about earlier, reached out to us and said, "Hey, I saw you guys do this giant wind tunnel study on tires." And he said, "Hey, I'd love to run them on rolling resistance." And I, at the time, didn't think much of it. And then he sent us the results, and I realized that we kind of been looking at designing wheels only half of the equation, because rolling resistance was a lot bigger component than I thought. And at that point, we started to realize that we had tested 25s in the wind tunnel for multiple different tires versus 23s. And even though aerodynamically they were slower at 25 millimeters, when you brought in the rolling resistance, it made them faster overall. So we rethought everything about how we designed this generation that it was just released. And we've optimized rims in a way that not only are we optimizing them for rolling resistance, but we're making them, aerodynamics, we're also optimizing them for rolling resistance. So we're able to lower the rolling resistance, which is the work that we do with you guys to prove it, by changing the actual makeup of the rim, which is pretty cool.
Yeah. So that's exciting stuff to when you really get down to it. Now, do some of the tire companies, do they actually match to you? Like, would Continental, say, okay, this is going to fit on really well on the Flo wheels versus this wheel? Like, do they do that, or do manufacturers just produce what they produce?
They produce what they produce, and so as a wheel designer, a wheel manufacturer, we're kind of limited in a couple things. Like, we have to think about the tire that goes on, so we're kind of designing around a tire within a frame.
Yeah.
Right. So we kind of have this box that we kind of have to play in. If I had my way, I'd make things a lot wider, but it doesn't fit most frames. Right. So we run into that situation. So we're kind of pigeonholed a little bit in what we do in that area and how we figure out how to make something really fast and really effective. There's other things too. I mean, you can really say, "Hey, we're going to do this one very specific thing, and we're going to make the perfect system, and at this yaw angle, it's the fastest thing in the world." But one thing that you have to think about when you're selling a product and manufacturing for a mass population is, how do we get something that's really good for a lot of pretty much everybody, right? And that's something that we really focus on a lot.
Okay. So let's talk just briefly about the aerodynamics of, and maybe there's not a difference. Is there a difference in tubeless versus tubed wheels for aerodynamics?
No, well, the only difference that you would see is if your tread pattern on your tire is different, right?
Okay,
So
but let's say it's the same.
if it's the
Like
same,
the
then
Continental
no,
GP 5000, tubeless, tubed, any difference in aerodynamics?
no. I mean,
Okay.
if we're considering them the same, then aerodynamics is basically what the wind sees. So how we inflate the tire doesn't matter at all.
Okay, so if I'm a consumer and
Mhm.
I'm going to buy a Flow wheel, I'm going to say, you know what, they optimized for the GP 5000.
Yep.
Now, I know you don't know everything about other manufacturers, but is that data available? Let's say I buy a DT Swiss wheel. Would I contact them, or would that be something that would be available on their website to know what they're optimized for?
Most companies don't put out any data on their
Okay.
products, which I have
Okay.
always found a little fascinating. And I don't mean to like talk poorly about anybody else, but I mean, I'm an engineering graduate. I consider myself a practicing engineer in this space. And one thing that I love if I buy a product is to understand how it works, why it works. You know, I want to understand the specs behind it. We took a very specific approach when we started to say we're going to kind of walk everybody through what we do and show them the results and let them make up their mind, because as a consumer, that's what I would want, you know. And I think that to be as honest and upfront as possible about how we do things and what it is, we want them to make an informed decision that works for them. Because
Yeah.
if somebody's trying to race and they're trying to get faster than just coming out with a product and saying these are fast, you know,
Yeah.
it's not the way we wanted to do it.
You
But
know,
most manufacturers don't.
I'm a little skeptical, to be honest with you. Not of you in any way,
Mm,
but of a company. Let's say they produce a wheel and they produce a tire, and they say, "Oh, this is the perfect combination.
mhm.
These two things, because we produce both of them."
Yep.
Well, they're trying to sell both of them as well, right?
Mhm.
And like, I really actually appreciate the fact that your company is saying, "Hey, you know, we optimized for a completely different manufacturer's
Yep.
wheel tire because the research shows it's a very, very fast tire."
Yeah.
If I look at, I'll say it. I mean, this is a podcast. You know, Specialized. You know, their newest wheels are supposedly optimized for their Turbo Cotton 26. Right.
Yep.
Well, how do I know? Like, of course, it's going to be optimized for their most expensive tire.
Mhm.
Right. I would expect nothing less from a big manufacturer, but
Yep.
I don't believe that, because I look at the rolling resistance on that tire, and it's middle of the road. Right.
And that, I think that just goes back to my point, and this is not a knock on Specialized, but I
Yeah.
think that tires are just a very, very difficult thing to make and to make well. It's
Yeah.
this joke that's kind of in the industry, and if you ask guys at Continental, they'll verify this. I'm not like spilling any beans or industry secrets here, but I remember years ago, a friend of mine who used to be the one of the head engineers over at Zip went over to the guys at Continental at Interbike and said, "How on earth did you make this tire? It's so aerodynamic." And they said, "It's what?" They said, "It's incredibly aerodynamic." And the guys at Continental said, "Well, we had no idea. We've never put
Yeah.
it in a wind tunnel." You know, so they just kind of fell upon this design
Yeah.
and it worked really, really well. And so then they're like, "Oh, I guess we actually have this really super aero tire." And, you know, back in the day, the guys at Zip were doing some pretty novel things from an aerodynamics perspective. And they tried with a lot of resources to try and produce a very aero tire, and they don't know why, but they couldn't
Yeah.
replicate what they had done it accidentally at Continental.
Yeah.
So
Do you want to know something interesting that from a consumer side is, and this always blows people's mind, where I'll spend more on a bike tire than I do on my car's tires, potentially, right? Like a Continental GP 5000 retail is $79.99,
yeah,
right? I can go to Big O Tires and buy a tire for my car for 59 bucks.
yep.
Might not be the best. It might not be the best tire. So maybe you could let us know, why are tires so expensive for bikes? Do you know? I'm just throwing this out
Oh
there.
man,
We didn't pre-talk about this. I'm just, just having a conversation here.
I think that there's, of what I do know about tires, there is quite a bit of. I think if you look at from a car tire perspective, those, number one, they're made in such mass volume. If you look at just
Yeah.
the volume of manufacturing of Continental
Yeah.
cycling, their cycling division of, and you look at Continental tires, is like less than 2% of what Continental does.
And that's probably and they're the biggest manufacturer probably of tires, I assume, in the world of bike
They're
tires.
Michelin, of bike tires, yeah, and they
Yeah.
make a ton of bike tires, right? And I
Yeah.
think that they make a decent number of car tires, but not. I mean,
Yeah.
they're not a Michelin, and I don't mean that
Right.
offensively to them, but
No, no.
it's just
Yeah.
saying that the volume's lower and higher in a
Yeah.
non-favorable way, and it's still less than 2%.
Yeah.
So, you if you think about it from a just from a manufacturing perspective, I think that the volume helps get them somewhat lower, but there is quite a bit of technology. A lot of tires as well are handmade. So
Oh, yeah.
there's an element of that that kind of goes in. A lot of the Continental stuff is still handmade in Germany. So there's that. There's a if you're looking at the Kevlar or the different components that are being used to make the tire, some of those become somewhat expensive.
Some are kind of exotic, like the graphene and
The
different yeah.
graphines and
Yeah.
Kevlars and different,
Yeah.
then you have your puncture strips and all these different things. So, and then I will be honest, I think that there's a part of it that it's cycling.
Yeah. It's a
People will pay
markup,
for it.
right? It's like this
Yeah.
is the fastest tire, so we can charge $80 for it when really, yeah, they probably could charge 40 and
Yeah. And I think too, you got to think about just the way that cycling's always worked is cycling has always been set up in a way where you have multiple lines of markup, which is how our business started in the first place, is that we sell consumer direct. So we cut out the distributor in the bike shop, right? It just brings
yeah.
down same quality products, same engineering and design. Just we sell it to you for a more affordable price because we cut out the markup. Well,
Yeah.
typically in any type of retail environment, if you're buying from a retail store, you're paying the markup is MSRP is 5 times what it costs them to make it.
Yeah.
So if you think about an $80 tire, you divide that by 5. I mean, you're probably around $16 to make.
Yeah.
That's pretty low. And but that's just the industry that we're in.
Yeah, that's the way it goes.
Yep.
Okay, well let's move on to the next piece then. Let's talk about rolling resistance because I
Yeah.
think I think people can imagine weight or see
Yeah.
weight. We talked about that. They can imagine aerodynamics,
Mm-hmm.
but rolling resistance is something I think that's relatively unknown for the average triathlete.
Yeah.
So, can you explain to us what rolling resistance is and why it matters for a triathlete or a cyclist?
So rolling resistance is basically the amount of energy that is lost as you roll a tire or wheel forward. So you got to think about what happens where the tire actually makes contact with the surface of the road. So when you get on a bike and you put your weight on it, you deform the bottom of the tire, and so it's called a contact patch. There's a flat section that is at the bottom of that. As that wheel rolls, the front of that contact patch, that's basically the piece that you would roll over, gets squished, and the back that's coming up is then expanded. So in that process of squishing and then expanding, it's called a hysteresis effect. You are you're losing energy through heat dissipation and sound. So that hysteresis effect is creating a loss of energy, and that is called rolling resistance. So and in order to measure that, you get something which is called the coefficient of rolling resistance, which is used in an equation to basically determine how many watts you are burning up by just rolling the wheel itself.
Okay.
So
Eh,
if you understand it, go ahead.
Okay, so you got a lot of technical stuff there.
Yeah.
Okay, so I want to dumb it down just a little bit.
Yeah.
Okay, so hysteresis. That's like my favorite word of the day. I'm writing it down.
Mhm.
Can you define that one more time for us and maybe a little bit simpler?
Yeah. Hysteresis is you've got to think of there's a certain amount of energy going into a system and a certain amount
Okay.
of energy coming out of a system. If I
Okay.
take like a bouncy ball and I hold it at my head height and I drop it and it
Yep.
bounces up a little bit and then eventually it stops bouncing,
Right.
right? What's happening is it's very similar to a tire, but every time it hits the ground, it compresses. And when it compresses, it creates heat. and it also produces a sound. And so then when it rebounds, it has lost some of its energy because it turned that kinetic energy falling into heat and sound, and then it comes back up. There's also drag, but we'll ignore that. Even if there wasn't drag, it would stop bouncing, right?
Okay, so that's hysteresis. Okay,
That
good. I love that.
hysteresis is, yeah.
I'm gonna start using that in a sentence this week. Just randomly and see how that goes.
Yeah. Yeah.
Okay, so keep going. Sorry to interrupt, but I
Yeah, no
really
problem.
wanted to stop you on that one.
Right. So let's assume that we now understand how this works. Just from basically we're losing energy because we're creating sound and we're creating heat where the tire actually hits the road, the contact patch,
Yeah.
as we roll. The question is how much does that matter? And that's takes
Yes.
me back to 2015, 16 when we had done the rolling resistance or the wind tunnel stuff, and then Tom Manholt approached us. What I learned, and it was funny because that same year I was in Kona, and the difference over like an Ironman from at the time a GP 4000 and the Continental Gator Skin, which ironically in a wind tunnel are almost identical. They're very close. Like the Gator Skin is a really aero tire, beats a lot of things that you wouldn't think it would beat. But the rolling resistance piece alone over an Ironman will lose you 8 minutes,
Oh,
right?
how much
That
do I have to train to gain 8 minutes? Like
it's a lot.
hours. Yeah.
It's a ton. And so that year at Kona, there was a very famous U.S. triathlete who I believe came in 10th and
We've
lost.
actually we've actually told this story. Yeah, Andy Potts.
Andy Potts lost
Yeah.
by less than 8 minutes and was in
Yeah.
10th place.
Yeah.
If he would have had a different tire choice, because he did ride Gator Skins that year, and a lot of people consider that at Kona because the roads there are notorious for like radial steel belt radial stuff, and you can puncture tires. But if he would have chosen a different tire and he would have not flatted, he probably would have been a contender to win, which is crazy to think about, you know? So it is that important. So right when we had done that study with Tom, I said, we really have to think about the wheel as a whole system. We can't just think about the aerodynamic component. We have to think, can we produce a rim that not only is very aerodynamic, but it also lowers rolling resistance? And we knew that wider tires were producing lower rolling resistance. So the theory was that if we could widen the internal structure, so the internal rim width, basically between where your brake tracks are, that we could also lower the rolling resistance of a given tire because it would in turn widen the casing width of the tire. The casing width of the tires, you think if you take a set of calipers and you were to measure how wide your tire is, the wider that internal rim width, that you get a little bit more width. And so that's when we did the research with you guys, and we worked with also a group up in Canada called Aerolab, and they had this
Yep.
sensor, and we were, I think, to my knowledge, we're the only ones who have really done any type of optimization around rolling resistance. I haven't seen it done anywhere else. And we kind of went up to them to get one of their beta sensors. And I think there was probably 6 or 7 companies that they were working with, and they're all looking at it from an aero perspective. And we wanted to come up with this algorithm that allowed us to, and test protocol that allowed us to measure specifically on-road rolling resistance. And what we thought was going to take a weekend, I'm sure they've maybe heard the story, took about
Yeah.
18 months. But we did it. We solved it and we proved it. And so all of the new wheels are optimized around 28 mil tires because we've also learned that from an aerodynamic perspective, it's not just depth; it's a combination of width and depth. So we've been able to actually take away some of the depth and widen things out and actually produce faster shapes. But they're also a much wider internal structure, which lowers your overall wattage consumption just because the rim width is changed by about 2 watts. So it's significant.
Yeah. Yeah. So 2 watts, for example, in an Ironman, I can't remember what it was. Is it like 1 watt per is like 30 seconds, something like that?
Yeah,
I can't remember
there's like the old rule. I think it's like 5 watts is, oh gosh, you're challenging me on
Sorry,
that. Yeah, no,
sorry.
that's totally fine. I think let me just pull up a chart here. I've got a bunch of data here. I can probably come up with it. But I know that the 2 watts that we're saying, I'll give you an example. So
Okay.
let me pull up our site so I can give you something specific. If I look at our Flow 64 AS, we have the total power consumption over, and let's just look at it from a like our Flow 60, which was the 2016 version, and then the Flow 64 AS. Uh, if I look at a 28 millimeter tire, it goes from 19.64 watts to 21.8 watts. So it's over 2 watts of difference for those two different wheels. The time savings that you're going to experience on a course, like let's say an Ironman, is about 6 minutes and 33 seconds for that. And so if I do the quick math on that, that would be
3 minutes a watt.
yeah, yeah. Because if I
About.
go back to the Open Pro, yeah, there's a significant saving, and I can put those numbers in the show notes if you want, but I can
Yeah,
give it
that'd be
for you.
great.
It's all based on it's based on your speed. There's so many different components that go into it, but there's some rules of thumb that you can kind of go off of for sure.
Yeah, yeah,
Yep.
awesome. So, is this something that a consumer could measure, or they just kind of got to go, well, this is what the manufacturer is saying, because there is a consumer piece, right? Because the person's weight, their bike, their setup,
Mhm.
potentially, can a consumer measure this?
Rolling resistance is really tough to measure on the road. Um, I know that Aerolab has released their sensor, and in order to use their sensor, they're recommending that you are using a trained fitter. One of the things that we do know and that we have realized is that if you're riding and trying to measure rolling resistance with this sensor, because it does take in the aerodynamics and your body position. So if your CDA, basically your profile that the wind sees changes at all, then your rolling resistance numbers kind of go out the window. So we
Yeah.
all three of us became very robotic riders.
Yes, we did.
If you turn your head and you're making a turn, it's screwed up. I mean,
It wasn't
anything.
it wasn't very comfortable riding for all those miles. And I
No,
think John Mercer rode the most miles, by the way.
oh, he did, man. He crushed it. I got to give it to him. It was funny. I remember we would send the files into the guy over at Aerolab, Chris Morton, brilliant guy, and he would look at the files and he go, "Yeah, Ted rode this one, Mercer rode this one." He could tell by looking at the data and how we
Yeah.
all rode in our unique styles. But yeah,
So
no,
in general, a consumer, the average triathlete, this is not something that they can just be like, I'm going to change my tires and be able to measure it on their own.
not easily. No,
Yeah, not
very
easily.
tough.
And if
No.
they were to get one of these Aerolab sensors, or there's a few other companies that sell them, which are very expensive,
Mhm.
and then it's still you have to know exactly what you're doing, and your protocol has got to be pretty dang tight. So in general, we just got to kind of trust that the manufacturers themselves, what they're producing, and not all manufacturers are doing this. Obviously, we were the first company. You were the first company. We were the first people to really to look at this. But so some general principles. Number one, wider to a certain point is better,
Mhm. You don't want to go
and
like you don't want a super wide. There's a width and safety issue, right?
right,
So if you go too wide, then you risk blowing off a tire. So you don't want to do
yeah,
that. So we're pretty much maxed out at what's safe.
yeah,
And there's obviously a safety factor there, so there's not really a concern. We use hooks on our rims, especially in the
yeah,
road situation, because some manufacturers on the roadside have started to go hookless, but you're extremely limited with the tires that you can use. And tires aren't really made in a road world yet where there's the tolerances are there. And so it does create some concern.
yeah.
Creating a rim with no hooks is more affordable, cheaper, allows you to bring in a lower price. But for us, it's just, we're not there yet. I don't think that
Yeah.
the tire technology is not there. So we're kind of boxed in by that to some extent, but
Yeah.
you're very safe with what we have.
Okay.
But yeah, the other thing that we do is we have charts on our website. So based on your weight, your tire size, your road surface, we give you recommended pressures to sort of
Yeah.
help you with that. We've been doing a lot of vibration studying coming up with you guys, where we're trying to do some prediction for some of that stuff with some potentially cool upcoming products that may or
Yeah.
may not have just received a patent that I'm pretty excited about. So yeah,
Well,
no, well, yeah,
let's actually. I want to pivot just a second because number
yep,
one, Yes, your website is awesome, by the way.
Thank you.
Even if, you know, even if you are not going to buy a set of Flow wheels, go to their website and look at all the information they have.
Mhm.
It is awesome. You guys have a great podcast as well.
Thank you.
I don't know what episode you're on. Like you're in the 30s, I think, right?
40s
Or
now. Yeah, we're
40s,
close
in
to
the
45.
40s
Yeah.
now. Lots of great information. If you're into this stuff and you're into basically becoming a faster cyclist in general, awesome stuff. And honestly, your website is just so chock full of content. I don't think there's another wheel manufacturer that's put out as much stuff as you guys have for the general public for us to learn.
Yeah.
And I commend you for that. You've really done a good job of educating people. So
Thank you.
let's pivot one more time and let's talk about about your patent.
Mm.
And I don't want to obviously give away too much. I'm gonna let
Mhm.
you give away what you want. But we talked off air about it, and both John Mercer and I are super excited to be potentially doing some more testing
Yep.
when this comes to fruition. So go ahead and let's share with what you can share.
What I will say is that I have thought for a very long time that there is a way to make cycling wheels intelligent. Um, there is a number of things that we can do from an aero perspective. There's a lot of things that we can do from a rolling resistance perspective. But once a product comes out of the mold, it kind of is what it is. It's just, there's no intelligence in it.
It's dumb.
It's dumb.
Yeah.
And it's kind of up to the discretion. So we have recently received a patent on some technology that we will be placing somewhere on a cycling wheel that will allow us to measure a bunch of things and hopefully allow us to have some artificial intelligence inside of a cycling wheel, which
Wow.
is pretty cool.
So tiny little robots inside of wheels.
Yeah, they're doing all kinds of things in there. They're blowing the wind away from you, and they're doing all
Exactly.
kinds of, yeah.
Well, I think that I got to be honest with you. I have a toothbrush that's a smart toothbrush,
Uh-huh.
right? It connects to my phone and it tells me, okay, switch.
Yep.
Oh, by the way, you need to replace the head on your toothbrush, which I think is honestly is completely ridiculous, right? Because I care less about my toothbrush than I do about my biking. I got to be
Yeah.
completely honest with you on that,
Yep.
right? Toothbrush 2 minutes a day, biking hopefully hours a day. So I'm super excited to personally to work with you. Do some testing for this wheel, but I'm really even more excited that this appears to be the first iteration of what we'll consider a smart wheel.
Mhm.
And I think it's super exciting for you, super exciting for your company,
Mhm.
and we're super excited to be working with you on this.
Yeah. Super excited to as well. Cool
Awesome.
stuff. Love what I
Okay,
do and excited about it.
I have one last question for you. I
Sure.
know we told you we'd kind of keep this to an hour, and we're coming up on it. And I just want, from a wheel manufacturer's point of view, where are we at on tube versus tubeless wheels, in your opinion?
Great question. Again, we are sort of boxed in by tires.
Okay.
If you got to think about it from where did tubeless start? And tubeless in cycling really started in mountain, right?
Right.
It was this thing that even back in the day, Stans, which was the founder basically of no tubes and tubeless and all that sort of stuff, they had a product that they were using that they were putting in tires that were not intended to be tubeless. And they actually approached a tire manufacturer and said, "Hey, we want to do this thing." And they said, "Your numbers aren't there and this is never going to work. No one's going to do this." And eventually they got some stuff to happen. We actually interviewed one of the guys from Sands on our podcast. So if you're interested in like sort of the history of tubeless, check it out. It's pretty cool.
Okay.
It was a cool episode. But anyway, make a long story short, it started to really take off in mountain biking. And what happened was they really started to look at how do we create tires that create a safe tubeless environment, safe tubeless setup. Everything started to go hookless for a number of reasons. But what they've done is there's a really, really good and tight tolerance at the bead hook or bead area of the tire. And so when you have a tire that goes onto a cycling wheel that's a mountain bike tire, as you inflate it, the amount that that tire itself expands at that bead is very, very, very little. So it's a really, really safe setup. Move over to road cycling. Most tires are not built in a way where under pressure they don't expand. They do expand. And so what happens is you get tires that will blow off. They're not really designed for tubeless. Rims aren't there from a hookless perspective yet. And you also experience a lot higher tire pressure in road and certain things like that. Now I do understand that the tire volume is a lot larger, and so casing tension's similar, but you are still seeing a lot higher tire pressures. So I do believe that we are going to make a shift. I think it's inevitable. I think most things will move over to tubeless, especially from a racing perspective. Tires are already on their way to becoming very good tubeless, and rims will eventually be there. The performance from a rolling resistance perspective is pretty similar to latex.
Yeah.
There's, some stuff there. The issue with latex has always been latex tubes are more difficult to work with than butyls. They kind of find anywhere they can find a hole. You can get pinch flats. They're expensive, but they're still, great tubes. Tubeless just gives you some of those benefits of if you ride enough. I always say, people say, should I go tubeless? I'm like, do you ride a couple times a week? Because if you don't, you're just going to basically lose all your sealant and it dries
Yeah.
up depending on your environment, right? So, but if you have it set up and you go through the initial headache of, which isn't really that big of a headache anymore, um, it's just your puncture resistance, your rolling resistance is great. It's a really efficient setup, and we're really making a push to tubeless here. We now ship all of our wheels with tubeless valves. It's just
Yeah.
something that we believe in, and yeah, I think it's going to be good eventually for
Okay.
sure.
So, do you have a video on your website of how to put a tubeless, how to do this?
Funny you
Because
should ask. I
because I
actually
have no idea how to do it.
this like a week from today,
Uh-huh.
I am working with a film crew here in Vegas, and we're doing a brand new how-to tutorial series. So that is actually one of the videos.
Okay, good.
And so, yeah, I'll be putting that together, and then I'm going to edit those videos and get them up. So there'll be a whole new series. A lot of the stuff that we've done since the last time we did that series, gosh, it would have been a few years ago now that we did that, but disc brakes are huge now. Tubeless
Yeah.
is a big thing. Through axle versus quick release versus all the different, XDR and XDR now. I mean, it's now XDR, but big changes from a free hub perspective. And so we're just kind of reshooting those to give people some more how-to videos.
I'm just gonna put this in. I hate disc brakes, and I have one bike with disc brakes, and my triathlon bike doesn't.
Mm-hmm.
And everyone's like, "Well, the braking's just so much better." I'm like, "I don't want to slow down. I want to go. I want to go fast, straight, fast." My disc brake bike. Oh my gosh, I have spent so many hours dealing with tick, 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 and rim and just I can't even imagine in the middle of a race if it started to rub, the psychological warfare that would go on in my mind. But I see it's happening, and I might be the last person on my race bike to actually switch. I'm just saying.
Unfortunately, I feel like we're all on a train that's just not stopping. And
I know.
I mean, I mean, we have the numbers. Disc brakes are slower
I
aerodynamically.
know.
They
I
are.
know.
I mean, it's a slower overall system, but it's the way we're going. I mean, we're
Yep.
moving in that direction. I would probably see a pretty full adoption probably by 2025.
Yep.
And it's we're just going that way.
Yep.
And I think that yeah, there are some benefits to it, but at the same time, like you're saying, there are some headaches around it. Um, Pros and cons, I guess it goes right
Yep.
back to that. But hopefully I still think there's a better way to make a disc brake. I just do. But
Yeah. There has to be some kind of something that can be done aerodynamically to make it better.
there's some, I've seen some patents around some things on
Yeah.
some internal hubs designs that are pretty
Yeah.
cool. There's some things that I think that will eventually shake out. It's just, especially if you're making brakes, you're really subject to like Shimano and SRAM. Like
Yeah.
if they're not adopting it, then I don't care
Forget it.
what patent you have. I don't care how cool your design is. It's
Yeah.
tough. I mean, they got a pretty strong foothold in, and right now they're making a big push. And you got to look at the big bike manufacturers right now. You look at their lines of bikes now; they're disc
Yeah.
brake. That's just
Yeah.
the way this thing's going.
So I'm looking at maybe I should buy another triathlon bike right now, because this is like the last time I might actually be able to buy a bike that actually still has rim brakes,
Hey man, don't
right?
don't be one of the 650C people.
I'm
Like,
gonna
but
I know. The weirdest thing is I'm on the cutting edge of everything, but
not
but
disc
this,
brakes.
but just not disc brakes, because, well, once again, because I think they're slower.
Ted's gonna be one of those
And
guys that
yeah,
calls me in 10 years and goes, "Do you guys make those
exactly.
rim brake wheels?" And I'm gonna be like, "No,
I
man, sorry, we don't
I
make those
know.
anymore."
I know. I'm gonna have to like have a whole like just shed full of wheels. And
Yeah,
oh yeah. And I hate to be like that, because I really am into like the science. And but if psychologically it's slower to me, and honestly that
it's tough. It's a tough pill to swallow. I'm with you.
it, yeah. So okay, so last question I have for you, I promise you this is the last one. Are you ever gonna make a kid's bike wheel?
Hmm. I don't know. We give a lot of bikes away to kids as
I
part of
know
our kid
that's
program,
what that was why I was asking.
but no, I don't think there's a
There's
super
not a
huge
market for
market
race
for.
wheels for kids.
I don't think so. I mean, I wish
Okay.
there was. I'd be all over it, but I don't think.
All right. Awesome.
I do actually do have my first child on the way, baby boy. So maybe I'll get some
That
inspiration when
that's
he's young to make him a set of wheels or something.
that's why we were asking.
Yeah, man. Wow, you're right on it. That's pretty cool.
All right. So, John, thank you so much for the time. We really do appreciate it. And like I said, we are super excited to be working with you and working with you in the future. And awesome that you always seem to have time for us in our podcast. We really do appreciate it. And we always like to have Vegas people on. And we
Good,
really do. I enjoyed this. I learned a lot, and I hope other people learned a lot as well. So thank you very
good.
much.
Always appreciate your guys' time as well. So thanks, and I'm sure we'll see you both soon.
All right, cool.
All
Hey,
right.
everybody. Thanks for joining us on Evidence-Based Triathlon Podcast. Have a safe ride this weekend. If you're out riding, safe run, safe swim. Just enjoy yourself. It's the off season for most of us. Get some base training in. Try to mellow out a little bit for the weekend. So have a good one.